No, 2. Log of 2.
Ja, jag gillar Serbien, jag gillar Putin. Om man säger det så får man president. Så är det.
Vad sa du första? Ja, det är det här gör det.
Separate all 3, do them.
Ja, men vad fan, det där går ju. Man switchar. Man gör så. Ja, exakt. Då kan jag bara switcha på X. Ja. Då blir det A-log... Ja, jag vet, jag menar det här. Jag bara är helt rätt att sätta göra som jag gör. Den andra kan jag inte göra.
Hej Gustav.
Och det var
Sista gäller det. Det är bara 36. Det är inte bara sådana som ett gånger. Det minns ju som de delar på. Jag kommer inte ihåg hur det ja, men det är ju ett gånger.
Yes, Gustav?
Det är samma sak.
Yeah, I don't know. I have purchased the application, but the application doesn't work. I probably need to talk to Remy for that. Yeah, hopefully it's fine. Okay, so we want to continue the topic of logarithm. Actually, we want to solve a little bit harder problems today. And I want to teach you how the last piece in this part, which is solving logarithmic equations. Yes, a logarithmic equation is also included in the book. So I don't know how many of you have the formulas in mind. If you don't have them, of course, these kinds of questions would be hard. And even if you have the formula sheet in front of you, if you do not practice so much, immediately understanding which formula is suitable for which problem is not that easy. So that's what I'm saying. Try to remember at least the famous formulas that you have so far. For example, you see that you have a log in the exponent. At least you need to remember there is a formula in which the log was in the exponent and it was useful. I don't know, by the way, if that formula is included in the formula sheet or not, because that's the definition of a logarithm. So can you remind me of that formula?
Which one again?
So because you see, if you remember what was going in the formulas that we actually talked together, there was one formula in which the log appears in the exponent. And you see that in this problem, I have logs appearing in the exponent all the time. So probably that is the only formula useful to solve this problem. If you cannot remember that, of course, it might be a little bit problematic, yes? Yes?
Yeah, so if the base is the same, then you can just look at the...
exactly. So that was this formula somehow. We have a to the log of b to the base a. This is equal to b.
And that's the case for 3 to the power of log base 3 of 36. It's just...
Yeah, that's exactly simple as that. So for the last one, we don't have any problems at all, yes? Because as you realize, so let me write number 1 here. You can do them step by step, by the way. Okay, so for example, you don't need to write them in one go. You can just solve each part. Even if you cannot solve the other part, still you have the chance to get a mark for that part, yes? Some points for that. So for example, as Rocco said, this is the simplest one. So let us start that one first. So 3 to the log of 36 to the base 3 is equal what? 36, no calculation needed. I'm just using this directly. Yes? Okay, but let us start from the beginning. 36 to the power of log of 5 to the base 6. Okay, so here I have 36. Unfortunately, this is 6. Okay, what is the natural step to take here? Yes?
You change 36 to 6
To the power of 2, yes? At least it seems natural. The goal is to make these two the same, yes? So then it becomes this to the power of log of 5 to the base 6. And then we know that these are multiplied. But there is another formula. Do you agree with me? If I have a to the power of m, then to the power of n, do you agree these two are the same?
Yes.
Yeah.
Yes, because then it becomes m times n, if this becomes n times m, they are exactly the same. So it means that if necessary, I can interchange the role of these two exponents, yes? And this is necessary. Let us do interchange, yes? So what happens, it becomes 6 to the log, 5 to the base 6, and then to the power of 2. Is that understandable? And now, again, can I use the similar formula? Yes. 6 and 6 are the same. The bases are the same, so everything will go away, and then I will have 5, but I have a power of 2 here, so then it becomes 25. So you see, it is not hard if you know what to do exactly. So then I will consider this one, 10 to the power of 1 minus log of 2. So what should I do here? What's your opinion? Yes, Kajal?
So I can say that it's 10 to the power of 1 divided by...
Thank you. Yes, thank you. 10 to the power of 1 divided by 10 to the log of 2. Which formula we are using? We are using a to the power of m minus n is equal to a to the power of m divided by a to the power of n. That's the formula. But what is the benefit of that? The benefit is that we don't have any problem with the numerator at all. It's just 10. But can I use the same formula for the denominator?
Yes.
Yes, because the base is not written down, so it means that the base is 10 by that convention. So this 10 and that 10 are the same. So I have exactly the same scenario. This becomes exactly equal to 2. Yes? Understandable? And then 10 over 2 is 5. So then if you want to, you can go back and write the question mark is equal to. The first number, what was it? It was 25 plus the second number here, we just got it, it is 5. So it becomes 25 plus 5 and then minus 36. So it becomes how much? Minus 6 is the answer. Yes? Okay, now let us go to the next problem. There is not a unique just way to calculate this. Might be you can start with more or less different ways. They change a little bit, but you will get the correct answer. Do you have any idea what to do? Anyone else? No one? Yes?
We could start off by changing 49 to 7 to the power of...
So you want to start from there. So let me follow you, okay? So you are saying that at least I don't have anything against that. And that is good, reasonable, yes? Because at least you see a base here, 7. This is 49. It's not completely unreasonable to write 49 to the power of 7, 7 to the power of 2. At least you are making these two the same somehow. So yes, let me follow you. So you are saying that I would write this is equal to 7 to the 2, and the whole expression, of course, in my handwriting, I cannot, yes, I can write it a little bit smaller, but when I type it with computer, you see that the fonts here are smaller. It means that all of these are actually the exponent of this. Okay, do you want yourself to continue?
I haven't done it yet, but I mean, I haven't even done anything more, but I could guess what you
Yes, yes,
So
just guess.
you start off by multiplying the whole other thing by 2.
2, yes, because I have some exponent. It is written in a fancy way, but who cares? If what is this at the end? That's just a single number. It's written in a complicated form, okay, but no problems. I just multiply these 2 by that. So then it becomes, but you need to be careful. How many terms I should multiply 2 by? 2. One of them is the 1, one of them is the whole expression. If I multiply 1 by 2, it becomes 2. What happens for the next one? If I multiply 2 by minus 4, minus 1 over 4, it becomes minus 1 over 2. And then I have log of 25 7.
Should I continue?
Yes, why not?
So, so 1/2 you can move it. You can move it to the to 25. So
Exactly. Yeah, that's actually a very nice thing. By the way, you can move this 1 over 2 somehow here and there. So let me talk about this a little bit. So if I give you 2 here, and I have A here and B here, if you want, you can move these 2 on top of this one. So you can write log of A to the 2B. But you can also move 2 here, but there is a condition to that. Do you know how to move it here? I want to move 2 on top of B somehow. Yes?
Isn't it 1 over 2?
It's 1 over 2. So if you remember, the rule was that if you want to take this one to the back of the log, you just take it as it is. But if there is something here, if you want to take it to the back of the log, you have to calculate the reciprocal and then put it here. So, and the other way around, so that's very nice. So it's very nice, by the way. You take 2 from here. So this is interesting to know. So I have a 2 here, and then I can write it as log of A to the base of B 1/2. So it means that I am taking 2 to the back of the log, and then move reciprocal to find the inverse and put it on top of here. So it means that if 2 goes from here to here, you can do that, but you need to do it as 1 over 2. So that's a nice formula to realize. Okay, so what you said is completely right. Of course, here I will not change this one because I see here is 7, so there is no good point if I want to change 7. So it means that this is completely logical. I will continue as Rocco said. Yes? So let me just continue. So then what happens? It becomes 7 to minus log 25 to the power of 1 over 2, and then I have 7.
So say the next step.
Yes, yes.
Yes. So 25 to the power of 1/2 is just the square root of 25, and that's equal to 5.
So it becomes 7 to the power of 2 log 5 7. So yes, it's actually much better than the previous situation. This is more reasonable than that, but if we can continue, why not? Can we?
Yeah, we can divide them by
Exactly, like Casual said. Yes, so 7 to the 2 divided by 7 to the log of 5 in the base 7. No problems with the numerator, yes? And now, no problems with the denominator. So the answer is exactly 49 over 5. So it's very important to be able to understand these questions. You should be able to calculate these things quickly. Yeah, probably it's a little bit above A-level question in the book. So yeah, so if you could solve it, it means that your mathematics is improving, yes? But no worries, I can make it harder for you. No questions so far? I am not saying this is the only way, but it was completely reasonable, so I followed Rocco. You might say that from the beginning, I do the division and then I use these rules, but that's up to you. So all of them will work, okay? So now let us go to a little bit more nicer problems, yes? So I don't know if they can be called nicer problems or not, but let me just write number 3 here for you.
Nicer means more difficult.
Yeah, always nicer means difficult. Yes, more. Yeah, non-trivial ones. Yes. It's no, I don't think this is harder. I don't know. Might be I am confused myself sometimes. This is easy, but just tell me what to do. I just want you to remind the formulas for yourself. So 27 to the log of 36 to the base 9. I can write one more. If you finalize, don't waste your time. So in principle, I should write this a little bit smaller. So let me just.
Oh yeah, you also.
Okay, anyone wants to answer number 3? So 2, no more. Don't hesitate to talk, okay? So that is encouraging for me as well. If I see that many people can solve, I will be happy, okay? So don't, how do you say in English, don't deprive me from something like that? Okay, so probably I deserve that. Yes. So Robert, do you want to say something? No problem. No problem. So Hussein, do you want to say?
I got the answer 6/3.
I don't know.
You don't know?
No.
Yeah, because I used the rule.
No, you just tell me what to do, and I will do that. If this is wrong, we just do it again. Don't get used to this way that everything should be perfect from the beginning. Most of the time, 99%, this is not possible. Most of the time, you have to write, cross it over, do once more. Try one other method. Okay, so just tell me what do you want to do.
The things I did was break out 27 to 3/3, and then log of 9 to 3/2,
And that's reasonable. At least this is reasonable. Why? Because we know that these two should be somehow the same if I want to calculate exact value without calculator. So it means that it motivates me try to make these two numbers the same, and immediately you'll realize that 27 is 3/3 and 9 is 3/2. So at least this is reasonable. Yes? So what we do, so you say we write 3/3, and then instead of this 9, I write 36 3/2. Okay, can you tell me now how to continue?
Yeah, I broke out 36 too, like 6/2 there.
Okay, if you want to do that, let us do that. But that is not very important here.
No.
Let us keep 36 to see how it goes. But let me follow you exactly. Okay, so you are saying that let me write this. By the way, let us ask you one nice question. Do you think I can cancel these two together?
Yeah, exactly.
It's very strange, yes?
Yeah, that's what I...
So, yes, you can cancel these two. It's a very strange way of cancellation in logarithm, yes? I can cancel these two with that two. Why? Because these two will go directly to the back.
Exactly.
But these two will be reversed, and go to the back. When it goes to the back, it becomes 2. This one goes to the back, becomes 1/2. They cancel each other.
That's exactly what
So it's a very nice way of cancellation, which is not a little bit counterintuitive, I would say, yes? how should I cancel this power with that power? But it works. Okay. But anyway, so I explained that. Yes, I don't need to write. So what do you say? You can write 3 to the 3, and then
Log
of 6 to the 3.
to the 3, exactly. And
Yes.
then you just change them up and cancel that.
So you can interchange these two now.
Exactly.
Yes. So it becomes 3 to the log of 6 to the 3, and then to the 3. So what's the answer?
6 over
6 to the 3. Yes. And this is 260.
Yes.
Yeah, that was very nice. But I would say everybody agree that this cancellation is possible.
Yeah.
Yes. Yeah. Okay. So anyone else about number 4? Yes, Abdul Manan.
And I started.
There is a formula you need to know. Otherwise, you will get.
your log of 5.
Yeah, exactly. If you don't know that formula, then you would be a little bit in trouble, because if you want to find the formula yourself in the question, it's a little bit hard. But this is one of those formulas which is absent in the book. But I want you to learn about that. So do you remember we talked about 1 over log of 3 over. Strange things can happen, yes? I can just bring it up and interchange 3 and 5. We showed that why this is reasonable. So when you need it, you can use it. Okay, so Abdul Manan, you said that I will bring it up and I will interchange the role of 3 and 5. So 5 goes there, 3 here. Usually when you see this, and if you have done your homework up to here good, you are relieved at this point. Yes?
You change 1 to 3 to
Exactly the same scenario. Yes? 81, you need to be a little bit with friends. Do you remember that 81 somehow is 3 to the 4? And then you have log of 5
And then you can change it.
interchange. Yes? So I can write 3 log 5 to the base 3 and then to the 4. And then this becomes 5 to the 4. This becomes 625. So 5 times 5 times 5 times.
Also,
Yes?
would it matter if you just sub at 5 to the power of 4 and not?
May you repeat?
Would it matter if you sub at 5 to the power of 4 and not continue?
Yes. Because if I want to buy something in the shop, if the salesman say that, okay, if I ask what's the price, the person says that the price is 5 to the 5, 4 crowns, it's harder for me to understand if someone says 625. For that reason, yes, it matters. Yes. And there are questions, of course, we do not have national tests, by the way. There are some questions that you are supposed, national tests, you are supposed to write the final answer. And if you write it like that, you will get 0 points according to the, I don't know, be a doming or whatever, what you want to according to that. You have to write it on this. Okay, now let me ask you one more thing here. Simplification. So I would say example and next example, simplify the following. So example, this is not hard, but I want to use the theorems in this problem. So example, simplify. Okay, so let me write it down here. So we have a log of the 3rd root of 16 to the base 2. And then I have plus log of the 4th root of 2 to the base 8 minus log of 27 multiplied by square root of 3 to the base 3. And finally, minus log of square root of 5 times square root of 5 to the base 5. Okay, so we want to simplify this. Of course, you know, simplification means probably you should be able to get an exact value. If not, simplify it as much as possible, but yeah.
Could you read the 3rd term?
This one?
Yeah.
Log of 27 multiplied by square root of 3 to the base 3. You're welcome. And I will write probably the pinnacle you call this, yes? Is that right?
Pinnacle, yeah.
Yeah, the highest level problem. That if you solve this problem, it means that you are guaranteeing your future probably. It's very simple, but I want you to understand how is it going. So A and B are real numbers and positive. Yeah, so let me write A and B are just positive. And of course, A and B are not equal to 1 because they are going to appear as the base. Simplify. We want to simplify. So B, so everything is on you. Interpretations, everything, if I can see, yes. Log of A in base 100 to the base 100, and then I have divided by log of A multiplied by same thing. I'm reversing the role of A and B now.
Am I supposed to do the upper one or?
Yeah, you can do both of them. After you are finished, don't waste your time.
Of course.
And then another exponent on top of that. And so let me, these are the dots, these are not mine. Okay, so this is nothing. So this dot is the product. This expression is the power of B, is the exponent of B. This expression is the exponent of A. And the whole expression is the exponent of the whole thing. Yes? So 2 times log of A plus B, let me make it sure that everything is right. Yes. Okay, I want you to think a little bit about these two.
If we can solve it, what did you say? Our future is guaranteed.
Yeah, in mathematics, it means that you can do a lot of things in mathematics. Because these are non-standard problems according to level of your lesson. Even this is probably much more than the level in the book, but they are manageable. You see, they are higher than the level of the book, but you can solve them easily. So I want you to understand, you shouldn't underestimate yourself. The books are actually underestimating too much, I think. Today at Kotevo, I am also going to teach logarithm a little bit, but I need to go fast, very, very fast. I would consider even I didn't see this question in the university text. The questions there are simpler. I can bring the university text next time. You see that you can solve all of them now. Okay? I would consider this even harder than the questions there. But it doesn't mean it is hard.
So,
yes?
So if you bring it to us, can you then go to your students and say, I brought this to first-year students and they did it, so you better solve it?
This attitude is absent here in Sweden, yes?
Okay.
This should be considered very rude if I say something like that. But I will try to say it, okay? If they cannot solve it, okay? But to be a little bit political, you know, politician. Yeah. If I say that this morning I gave it to my high school students in the first grade, and then I ask, okay, what is your opinion about that? I know everyone will keep silence. Yeah, you need to. This is very important. Don't consider people judging you or evaluating you. That's not their business. That's your life. And I am on public now, and I really don't care. Okay. So everyone in principle, afterwards, no one will see me. I'm not that famous. But anyway, even if I was famous, I didn't care. Yes? So I am doing my job. It might happen that I am making mistakes, and I did mistakes sometimes. If you have seen my videos, I have some comments below them. I realized that, okay, that was a mistake, but I give a comment there. I made 2 to 3, 3 to 4, something like that. So don't start here. I want you to finalize this and then start here, okay?
Just one question. Is that gonna be like the whole number? That is.
I don't know, but my way of thinking is yes. It's the whole number. I don't know, but it would be a number at the end.
Do you want me to write it as a fraction, maybe? Or?
Yeah, fraction. Always with fractions. If you want to do it with decimal points, usually it's not good. How many of you did this one? Finished or not? Not yet. Okay. Okay, continue and finish the first one. That's completely at the level. I think I am combining more terms, but I would say each one of them, except probably the last one, is at the level of the book. For example, A level in the book. But if you have listened to me, you also need to understand what to do with the last one. Did you finish this? The second one as well? What's the answer?
It's improvised. Yeah.
Yeah, but it's for.
Inte det jag fick, jag kan råka köra fel. Det är inte säkert. Jag kan kolla.
Just one question: is that root included?
Yeah.
Root of 5 is.
Yeah. 5 square root of 5 in total is under a square root sign.
Sure.
Okay, do you want me to start now?
I'm almost done with the last one, so like
Okay.
just a minute more.
Okay.
Det är inte 4, det är nej. Men det är 2, men det är samma som den här, det är samma som så fick vi ja.
Alltså, jag har fått någon fraction på det. Ja, jag ska bara
Jag tror jag hade en små fel.
för jag fick en 8-del av att det är därför jag frågar om de var båda included, för då skulle det där vara jag vet inte. Jag fick det på den sista.
Jag fick
Yeah, it's very good to improve the spirit of competition somehow. Yes, it's important because then you will start, become a professional. If you want to run, you really run for being the first. So why not in solving problems? Of course, I don't want to bring a stress for you or something, but this this constructive competition is really nice everywhere. Yeah, so then you will go home and start memorizing formulas because you want to be the first to answer. Yes, and this is instructive, by the way. At the end, you will gain a lot. So, for example, in Iran entrance exam, this you have only 90 seconds. Okay, so this is the way they train. Even in Indian universities, more horrible questions, you have only 2 minutes. You cannot compare this question with the level of Indian entrance universities, yes? So it's horrible, I don't know how they manage it. But speed is very important in calculation. Of course, understanding is the first building block. After that, speed is also very good. Okay, so let us do this one. So how do you solve this problem? Okay, so let me solve this problem. Please communicate with me to solve this problem. Let me write with black so that we can see it on the video much better. Okay, so what do you think about? Every one of you hopefully understand what is the problem, yes? This is 2, the base is 2, and this is somehow related to 2 to somehow. The same scenario here, 8 and 2, 3 and 27 and 3, 5 and 5 and 5. Yeah, so it's completely clear what you need to do. Okay, do it fast. Okay, so how we can do that? So for example, doing it fast, it means that do some part of it in your head. If you understand the goal, what is the goal here? You want to write this as a power of 2. Can you do it in your head or not? So let us just do that. So you have the log. Can I do something? The way, you see, I think all of these things, but I have trained my brain to think quickly. I do not touch it at all. I don't know, it doesn't take any seconds for me to understand not to do something with 2, but I know what to do with this one. What should I do? I want to write it as a power of 2, yes? 2 over 4, and do both, okay, after 2 to the power of 4, then what's the next step? Do it in one go. Why do you want to do it step by step? Step by step in your head, but not on the paper. So what's the next step? Yes, do it. Just do it quickly. So what is the answer? 2 to the power of what I should write at the end? Finished. Even if you go one step, you don't need to do. You just write 4/3 because you know that this will go back. Log of 2 in 2 is just, you just write 4/3, as simple as that. Okay? Don't try. Think. I am also thinking every step that I am taking because this is mathematics. You have to be very, very precise from one step to the other, but you really don't need to write every detail. Okay? In the exam, write the details. But we are having fun here. Just we want to make it as quick as possible. Anyway, at least do it in one go. Write it like that. But I am completely sure if I write 4/3, everyone agrees this. So in principle, by just looking at this is crying out, I am 4/3. Yes? So you need to think in this way. Okay, can you just do something there? Let us keep it like that. And then next one.
Wait.
Yes.
Sorry, can't you simplify it more?
Yes, of course. I told you this will go there.
Okay.
So the whole expression for me is just a matter of seconds to understand the whole combination 4/3. This is not because I am genius or whatever. Because when I was learning, I cared about being fast. Of course, you are not in a hurry to be very fast. But when you can do something faster, why don't you want to do it? And it is possible. Try to value it. That's my point. Not in the exam, here in the class. Okay. So let us stop here, because if I just write 4/3, when you go back to see your notes, you will be confused, okay? But now hopefully everyone understands. Everyone, so what I wrote, the 3rd root of 16, if you want to write it in the exam, it should be like that. Yes? Is that understandable? And of course, it needs that you have this in your memory. Otherwise, you need to go to look in the formula sheet for each step that you are taking. And then you always complain the exam time was not enough. Yes, probably there is a misunderstanding between you and me. I will always think that this is enough. Why do you say it's not enough? And that's the reason, probably. Yes? Okay, now let us go. Let us go to the next one. How do you think about this problem? At least do some parts. So what should I write for the 4th root of 2? You have enough experience. This is not, you are not black-minded right now. You have a lot of experience, so why do you lose time for it? So what should I write for the 4th root? I should write 2 to the quarter, yes? So let me just write that. But now you have enough experience. This is somehow not useful for my problem. It should be somehow related to 2, but then immediately it is 2 to the 3. Yes? So let me just write 2 to the 3. And let us go to the next one. Can you do this in your head now? What is your, so 3, I cannot do anything, so let us copy and paste that. But in your head, 27 times the square root of 3. What should I write? This, yes?
3 to the power 3.
No, finalized form.
Finalized form is,
Yes.
I wrote 3/2.
Finalized form. So how I think about this problem? Yes, it is 7/2. 3 to the power of 7/2. Can you see why? Because 27 is what? Everyone agrees. What is 27? 3 to the power of 3, yes? And what is a square root of 3?
3 to the power of half.
Okay. So do you really have trouble with adding 3 to 1/2? So what's the answer? 7/2. Yes? Yes or not? So you see, if you want to think, or you are making things very big in your head, they are not that big. You're human. Come on. Yes, these are just very simple numbers. Is that understandable for everyone? Which part of it you didn't know? You need to take lesson right now if you like mathematics. If you don't like mathematics, okay, so 3 plus 1/2. Pardon? This becomes 3.5. I agree? 3.5 is 7/2. Yes? But be careful. You have to be very quick. You have to be quick in these simple calculations. So now, if you have big problem to understand that this is this number, then of course you will be in trouble. Everyone agrees with me? Yes or no?
Yes.
Okay. If you value it, if you don't value it, you will not learn it. This is what I want you to understand. If you don't value a little bit faster calculation, then you will actually always in the slow mode, okay? So let me clean it. Now let us go to the next one. Might be you find this horrible, but is it?
I think.
So what is the final answer to that nasty square roots?
3/4.
Yeah, the power you mean.
Like the answer. Well, the power will be
3/4.
Yes,
Yes, that's correct. Yes. So how we should do that? So what I do, for example, square root of 5 is square root of 5. So what is the power of 1 here? Yeah, I want to feel it now. You have studied this before. So if I ask you, first of all, you shouldn't get confused. Is this something horrible for you? No. Why not? Because if I ask you square root of 4, you can immediately answer. This is what you need to teach yourself. No teacher can teach you this. If you don't have any problem here, but if suddenly I put here something like 5, you don't have any problems. You know that you cannot answer it exactly, but you are familiar with this. But as soon as I make it a little bit more complicated, you get confused. But the nature of this problem and that problem are exactly the same. The only thing is that instead of putting a very nice number 4 there, you are putting a very strange number 5, square root of 5. But they are the same thing, yes? So that's important. Okay, so what should I do? I will ask myself, what is this one? This is the product. So what is the power? What is the exponent of 5 here? Everyone knows this is 1. What is the exponent of 5 here? 1/2. I am multiplying them. What is the rule? The rule is to add them. So it becomes 3/2. As simple as that. It is 5 to the 3/2. Yes or no? And now you are taking a square root of a number. So what does it mean? So you see, if you have problems in these steps, you need to review what I told you and try to remember these ideas. Because these ideas are repeating themselves over and over again. Okay, and then what's the answer to this immediately? This is a power, another power, I have to multiply them. So as Rocco said, the exponent is 3/4. But you see, it shouldn't take more than 2 or 3 seconds for you to come from here to there. It's not hard. If you don't value it, you will not learn it. You would say, why should I care about speed? Yes, why not? In everyday life, you always care about speed. You're playing, video games and everything. Every people are caring about speeds. But suddenly in mathematics, you want to be relaxed. No, don't be relaxed. Try to be fast. Okay? So now, what should I write here? The answer is minus log of 5 to the power of 3/4 in the base of 5. Everyone agrees now? Okay. So let me not clean it. If you haven't understood, you can later just revise it. But then, what is the answer? This doesn't have any problem. What's the answer in your head? What's the answer to the whole combination here? What? 4/3. Why? Because 4/3 goes to the back, and then you have log of 2 in the base 2. You remind yourself about theorem. Log of 2 in base 2 is just what? 1. So this is 4/3. Okay. Now, this one, we don't have any problem. So let me write a plus, an empty space. What's the answer to this third one? 7/2. Thank you. What's the next one? 3/4. And now, can you tell me what is this one? 5 seconds. 1, 2, 3, 4, 5. Finish. One more. 1, 2, 3, 4, 5. Finish. What? Yes, thank you. 1/12. So it works, yes? In 10 seconds, you answer. So why this is 1/12? Because this goes directly to the back. 1/4, yes?
Yes, and then you inverse the...
It becomes what? 1/3. You have a 1/4 already there. This becomes, so 1/4 is already there. 1/3 will go there. They will be multiplied. It becomes 1/12. What is left? Log of 2 into the base 2, which is 1. Okay? Now calculate this 10 seconds. 1, 2, 3, 4, 5. Yeah, calculate.
17.
Calculate. It takes 10 seconds for you to just wake up. Okay. Just solve it. I don't know the answer. But I know it's still 2021. Come on, what's the answer? Yes?
Minus 34.
Minus
34 over 12.
over 12. I don't like it. Because your brain doesn't appreciate simplification. Yes? At least you should tell me minus 17 over 6. Then I will like it. This is correct, but if you do not simplify, if it's a national exam, you will lose some points. Okay? So let us see. Nicholas, this is the answer. So minus 17 over... So your reputation is on stake. Okay, just say something.
What?
Yes, everyone else. Agree? Yes,
agree.
Robert, Nicholas, how many of you agree with this one? Okay, good. So it works. You see, if you appreciate the speed, it will come. Okay? Okay, so how should I calculate? How did you calculate? 3, 4. You see, it shouldn't take so long because adding fractions, you need to know the rule immediately in your head. It shouldn't take time from you to understand, okay, where I'm supposed to do, what I'm supposed to do. No, you know common denominator, yes? And the common denominator, 3, 12, 2, 4. What's that? What? What? No, you said something correct. What was that?
12.
12, yes, why not? 12 is the best choice. Yes? So here, 4 times. Yes? So it becomes how much? 16. 1 times. It becomes positive 1. 6 times, minus 42. 3 times, minus 9. Yes? And then you start adding them. So what is the answer here? This one and this one, minus 25, minus 34. Divided by 12, but do not stop there because you will lose some points usually in exams. So 17 over 6. Yes? So we were able to calculate this even better than calculator. I don't know if you put this in total. You need to put it in total in your calculator and to see that if you can confirm this is the exact value. Because if you want to punch it one by one, you get decimal points. And of course, in Casio calculator, I think if you know how to punch this, you will get the correct answer. It's also it's a skill that you need to learn. Don't have trouble to put this in the calculator. Okay? So you see, but you really don't need any calculators to calculate this one. Okay, let us start the fun part now here. Okay, so we have already got the correct answer by Cameron. Okay, but let us see how you want to solve. Okay, I can check your answer. Okay, I don't want to expose it.
Please check my answer.
Yes, two correct answers. 2 correct answers. No, just yeah. Try to solve it. Don't give up. Don't give up. You will not learn anything if you are not stubborn. How do you call it in English? I think it's correct, yes? If you're not stubborn, you will not learn something. Okay, so how we can solve this problem? I want to teach you the skills. Of course, I don't know. How do you think about the problem? Can you talk about this problem? The first time you see this problem, it seems a little bit horrible. What do you think about the problem? I want to hear from you. Might be I can correct you. You shouldn't say that I don't have any opinion about this. Yes, Rocco?
So wasn't there some power rule that if they have the same exponent, you can like put them in brackets or something? If
So you mean that you want to use this somehow, this rule? Something like this, you mean?
yes, something like that.
Okay, but isn't it horrible here?
It is horrible.
It's horrible. Don't do it. Okay, this is the first thing that you need to learn. If there is a gun in your head, yes, you have to do something, otherwise you will be killed. But in mathematics, especially nice problems are not problems that you start the easiest way to do it. It might work, but then it becomes so messy that you cannot control it. So yes, these are the formulas that comes to your mind. Yes, you are right. This is a product. If I want to use this formula directly, I need to put this big thing in brackets and put another power of that, and then multiply these things. Might be it work. I'm not saying it's not working. But if I were you, I will not start using exactly this.
Well, you asked me for my opinion.
No, that's very good. This is what you learned. Even though this formula is valid, so this is the problem. In mathematics, you need to find the best way to do it. Okay? So if you start from here, nobody say that is wrong. People start reading what you are writing. They do not say, okay, this is useless, I don't care. No. If you are following the logic, people start reading your what you have written. And at some point, if it is reasonable, it's not reasonable, they will stop there. But what is my problem? If you want to be a good mathematics problem solver, you need to learn these tricks and techniques. Okay, I want to hear another opinion. You can also give another opinion. Yes, Kajol?
Okay, so could we say that the exponent of b, you can say log of 10, log of a in base 10 to the power of 2, because you can write 100 as 10 to the power of 2.
To the power of 1/2.
So you see, you missed this single point. So it means that, so what I was thinking, if I want to solve this problem, I don't know, I have trained my brain. I do not look immediately here. I will look here a little bit, but I realize that can I get rid of this bad exponent? I will focus here. I don't know how, but probably if you train yourself, you will also learn that. But this doesn't mean that you can solve all the problems. 99% I cannot solve the problems. Only 1% I succeed to solve the problems. Okay, if you make the problems hard. But this is the nature. Okay, this is the nature, and you enjoy exactly because you cannot solve the problem. Yes, I would always say that if you like spicy food, it's exactly because you feel burned in your tongue. Yes, that's exactly the same reason you take spicy food. But otherwise, oh, it's too hot, I will not take it. Why not? You eat it because you want to burn. Okay, that's exactly the same scenario. So Kajol is saying that, okay, this is a very important skill. If the problem is horrible, learn this trick to break it into smaller pieces. This is not hard. This is something everyone can learn. Okay, I see that there is a horrible part here. And then I am happy. There is no big difference between these two. Only the letter is changed. So let me start from here, go to a scratch paper, and try to see, can I do something here? Yes, can I do something here? Okay, so you realize that it is every one of you knows, but you see why you don't use it, you need to ask yourself. What is 100? Everyone knows it is 10 to the power of 2. And then, okay, yes. And then log of a. But can you tell me what happens for this? If you have forgotten, we reviewed it exactly today. What happens for this power of 2? Yes? It half goes there, yes? But do you agree with me that I can write it as just this?
Yes.
Because the base is 10 now, and I don't need to write it down. Now, isn't it interesting? Okay. Do you feel any doubt that you can simplify these two?
Yes, you can do that. Yeah.
Yes, we can do that. So what's the answer? Okay, so this problem was actually, this is nothing except 1/2. Which one is better for you? 1/2 or this horrible situation? Yes, 1/2 is much better. But do even we need to calculate this? It's exactly instead of A, I have B. So that's also 1/2. Now your formula becomes actually very helpful, right? Because you see, now the question mark is equal to B to the power of 1/2, and then A to the power of 1/2, and then I have 2 to the power of log of A plus B in the base AB. Yes? Yes or no? Yes.
Yeah.
And now, what? So can you just continue yourself?
Yeah. So we do. Then we do B to the power of 1/2 to the power of that number times A to the power of 1/2 to the times of that.
Exactly. But if I were you, I wouldn't do that. If I want to do this, because I'm lazy, this is very important to remember. You should be a lazy person in writing. I would write this like this. BA to the power of 1/2 comes out instead of, so you see P, this one. Do you agree that I can write it as BA to the power of 1/2? Yes. And then if I have this 1/2, there is another power of 2 here. So what is the answer? This 1/2 will be multiplied by this exponent. This will kill this one. So what happens? It is BA or AB to the power of log of A plus B in the base AB. Agree? Yes or no? And what's the answer? A plus B. We are done. So you see, you need to improve your skills. If you like it, if you don't like it, of course that's a different problem. But if you like it, but you don't know how to do it, I am trying to give you these hints. If you follow, you will actually improve your problem solving skills. Are you ready for a challenging one? A more challenging one? A more challenging. Okay, so let me try to find something. I don't know. This book is actually a Persian book. It is designed for gifted students. But it was, you really didn't need to be so gifted to solve this. Yes. Yeah. Okay, let me ask you another question. Let me see which one catches my eyes, you know. Okay, this is a very simple problem, but let me ask your opinion about that. Let me ask your opinion about that.
Like we can disagree with you.
Yes, of course, you always can disagree with me, but I don't promise to care. I'm just kidding. I always care. Okay, so here I give you a very simple problem, but I don't give you the right-hand side. In this problem, the right-hand side is also given. Because if I give you the right-hand side, that's a very big hint. Okay, it's a very simple problem. Okay, simplify this guy as much as possible. So first of all, I have to write it in a small fonts. It's the whole expression is the exponent of A, and I'm assuming A is positive. A is not equal to 1, okay? And then I am asking you this. I am asking you to tell me what is the meaning of log of A. We talked about this, but I intentionally put a pair of brackets around that, if you remember. This means that you calculate log of A, it becomes a number, and then from the new number you take another log. But nobody writes pair of brackets because there is no matter of confusion, you know? Because if I don't write it, I will not lose anything, and that's a general principle in mathematics. Be lazy as much as possible. Yes. If you write log of A, everyone, if you understand, you should interpret it in this way. There is no matter of confusion. Can people write this product? Yes or no? Yes or no?
No.
Can people read this as a product of log by log of A? Yes or no? Yes or no?
No.
Why not?
The question will be too easy.
No, why too easy? So can you, my question is that these are the questions that you yourself need to understand immediately. Do you think if I don't put a pair of brackets around them, is there this confusion? There is this confusion that people read it as log times log of a. Is it a good interpretation of this log and log? Yes?
I would say no, because log needs to have one number.
Very good. You see that this is a very, very important thing. This is a deep understanding. Why you might underestimate this, but I have seen people doing this. You see, people write this like that. How many of you agree with this?
It's wrong.
It's wrong because they are factoring log out. Log doesn't have any identity on itself unless it is acting on a number. After log is acting on a number, then it becomes a number. Then I can use the root. So it is a good understanding. Exactly. So this is no matter of confusion. Okay, now I want to wait for you. And I want to write your answers here to see how many of you simplify this as much as possible. A is positive, not equal to 1. And that is a good time if you review the formulas, because in this way, the formula will go to your memory, which you need it from my perspective. If you are, yes? Just write it. No. Because I have the answer here, I haven't calculated myself, but that is not the answer. So let me write it a little bit close here. So a to the power of this, yes. Did you get it?
Maybe.
I see. Yes.
Baba, would you say I'm on the right track?
Yeah, but it says yes. But can you just give me the logic?
Oh, so
I want to see.
maybe okay. I don't know if I wrote it correctly. I was thinking possibly if I had.
Yeah, but it's for
It's very good, but
If I didn't write something here, maybe.
just redo it again. Assume that this is now exam. Okay, so you found the answer. If you're sure about that, you should be able to motivate me by writing.
I could motivate it if you ask.
Yes, I will.
Okay.
So now you see it works. If you try to think, you can be a good problem solver.
But to be clear, in the actual questions, they show the other side too. So you took a problem for gifted students and made it harder.
I made it a little bit harder, but I can promise there are much more challenging questions that you haven't imagined yet. I'm sure.
Yes, made it harder. I made it more fun.
Ah, yeah. Okay, so let us hear from you. So I saw the Rocco solution; it was correct. Cameron's solution was also correct. But any other opinions here? How do you think about the problem, except Rocco and Cameron? Let me ask you one question. If I ask you to write something in front of this, can you tell me? Just raise your hand, please. Not Rocco. Okay, if I ask you to write something in front of it, which is correct? Which formula comes to your mind, if any? Abdul Manan?
Log of 2, the log of 2 base 3.
Very good. And what I'm saying is that you need to broaden your points of view. When I write it more complicated, you cannot see it. And that is the only thing that you need to learn in mathematics. So you see, how many of you? So someone else except Abdul Manan. Why this formula? Why what Abdul Manan said is correct here? Why? Someone else describe it for me. Of course, if you don't have any clue, then you have a hard problem to solve this. This is why I'm saying that at least you need to know once upon a time there was a formula which was useful. If you totally forget, you will never go to the formula sheet because you don't know, you are missing a formula or you are missing the concept totally. These are important things that I am telling you. Please appreciate that. I will make a lot of trouble for you next year. So yeah, be prepared. Yeah. So here, log of 2 divided by log of 3. Can you give me a name for this, what I used, or can you describe it for me? If you don't understand it, I can remind you. But I hope that someone except Abdul Manan and Cameron and Rocco knows about this. Why this is correct? Okay, so that was not a very surprising that you couldn't solve. You see, memory plays a very vital role. Did you remember this?
Yeah.
Yes. So you used it. Okay. I'm not saying that if you remember it 100%, it is guaranteed you will find the answer. But one thing is clear: if you have forgotten, 100% you will fail. 99% you will fail unless you start doing everything from scratch. Okay, that was a formula. I told you for some reason it is absent in the book, but I talked about that. It is the change of basis formula in the log. Okay, so I told you that if you have a log b to the base a, you can write it as the log of b to any base that you like, divided by the log of this one in the same base. It means that from the base a, I have switched to base C. This is called the change base, base change formula in the log. So here, the base was 3. What is the base here and here? It's 10. So I have switched to base 10. So now I want to ask Abdul Manan. So you knew about this formula. You need to take a lesson. Why, even though you knew the formula, you were not able to detect the pattern? Exactly, if you don't pay attention to this, what I'm saying right now, you will make the same mistake for the next problem. Unless you take this as a toolbox and put it in your pocket. You need to remember it somehow. Okay, so you see, now let me go here. This you need to understand very good in mathematics. I will give this a name. This makes a trouble for me, okay? Now I am asking you the same question. Log, this becomes m. This is log of a. What is this one now? If I ask you this, you knew that. But because of an extra log, I was able to make you confused. This is exactly what you need to learn, and it is doable if you want to learn. What is the answer to this, everyone, according to this pattern? It's the log of n to the base a. Yes? So now, if I ask you, so immediately you recognize what's going on. So this trick, don't let the people fool you, okay? They are making the problems harder by making these combinations, that's it. Okay, so then this becomes equal to A. Can you tell me what's the answer?
Log
This becomes log M to the base A, but you know this formula, was it hard? It's just M. But what is M?
Log A.
Log A. End of the story. So A to this fancy combination is nothing except log of A. Is that understandable? Yeah. So you need to learn these tricks. You will not learn them if you don't value them. Do you want a more challenging problem now?
Yes.
Okay, let us see how this goes. Okay, I don't think. Let me write something here for you.
Something to teach too.
Yes, but don't worry about that. Let's enjoy life.
Okay.
I will also teach that one, but yes, we can have some nice problems also there. So let me talk about these logarithmic equations. Okay, any one of you can define a logarithmic equation for me before I teach you. What is a logarithmic equation? What do you think? Yes?
The inverse of the exponential.
Now, logarithmic equation. Yes, of course, that's the definition, in a more advanced definition of the logarithm. It's the inverse of the exponential function. And that's exactly what I'm going to teach today, okay? But we don't need that. I'm just asking you this question. What do you think would be my definition of a logarithmic equation? So this, I want you to start being a good teacher yourself. Yes. So what's the meaning of a logarithmic equation? Yes. What's your opinion?
Equation with logarithms in it.
Yes. 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 So what? Yeah, that's correct. But make it a little bit better.
So like.
So for example, do you consider this a logarithmic equation? X times log of 5 is equal to 10. Is it a logarithmic equation?
Yes, it contains a log.
So according to your definition, this is a logarithmic equation. But according to what I want to define, this is not a logarithmic equation.
Maybe it's like something where there's a variable in the logarithm.
Exactly. So the unknown should appear inside the log symbol, either as the base or in front of it. Yes, by the way, what is the answer, everyone? What's the answer to this question? Find x. Yes?
10 divided by log of x.
Yes, it should be a matter of half a second to understand that x is 10 divided by this. If you don't understand, you need to revise your brain. What is happening in your brain? Okay? I told you, what is this one at the end of the day?
Just a number.
It's a number. And if I give you x times 7 equals to 10, how much does it take for you to find x for me? But when it comes to this problem, you just stare to the whiteboard. This you need to teach yourself. The only thing that I can do is just to draw attention to it. But that is up to you to learn this from me. If you can solve this problem, technically, you have everything at your disposal to immediately answer this question. If not, you are the problem, not mathematics. So you need to fix it in your brain. Everybody agrees now?
Yeah.
The nature of this problem is mathematically equivalent to this problem. So in principle, this is not a logarithmic equation because we didn't do something new in it. As now Rocco said, the complete definition of a logarithmic equation is an equation. What does it mean by an equation? It means that you have equality somewhere there. Yes, this is the meaning of an equation. And then you have an unknown, at least one unknown in that equation. But logarithmic equation means that your unknown should appear inside the log symbol, either as the base to one of the logarithms or appears in front of the other logarithm. Yes? So we know the definition. Yes? Is that clear? So this is, you need to be able, I don't know, for example, next year we talk about trigonometric equations. Remember it from here up to next year, to be able to define it for you. Okay? So here, if I want to solve the logarithmic equation, then there is something very important. Okay, if I have a log, for example, if x is in front of this one, let us make it as simple as possible. I give you this equals to 5. So is this a logarithmic equation? Is it or not?
Yes.
Yes. I have a log. My unknown appears somewhere in this log, and I want to find x. But I don't need to teach it to you. Every one of you knows about that. What's x? 10 to power of 5, which is 100,000. Yes? So this means that x is equal to 10 to the power of 5, which becomes with 5 zeros, 100,000. Yes? Now, let me give you another scenario. Do you think that this is a logarithmic equation or not?
Yes.
Is this a logarithmic equation?
Yeah.
Yes. Equality, unknown appears inside the log sign, but it is appearing as the base. Okay, but I don't need to teach it at all. Can you solve this for me? So it means x to the 2 is equal to 5, yes? So this means that x to the 2 is equal to 5. So what is x? No. What is x? Plus or minus? It's not a decoration. Plus minus is necessary. Okay, but am I solving this equation? No, I am solving this equation. Do you remember I was talking about the reverse direction? Yes.
If x is the base, you can't be minus then.
Yes, exactly. That's what I'm saying. What I'm saying is that, do you remember the root equations? We squared the root equations, then I talked about something which is called the false root. You find it, but you realize this is not one of the solutions of the original equation. Do you remember what was the origin of something like that? Yes?
The irreversibility of
Exactly. Thank you very much. So some operations are not reversible. Yes? This is one of those operations. So from here, I can conclude either that one or that one. In this direction, I also have that reversibility, but we need to be careful. X cannot be negative. Yes? So the solution to this problem is up to here, but you shouldn't be hurry and put this in a box. You should say that x equals to minus the square root of 5 is not acceptable, because based on the definition of a log, we know that this number should be positive and not equal to 1. So this is a fake root. So the answer is just x equals to square root of 5. Yes? So, but this is necessary. You have to write both of them, explain it, and remove it. Okay? Otherwise, I will not accept it from you in this. Is that understandable?
Yes.
Okay. But now, another type of logarithmic equations are also possible. Here, I am giving you a log equal to a number. What happens if I have two logs equal to each other? So, for example, a log of x in base 5, let me write it x plus 1 in base 5 is equal to log of 7 in base 5. Is it a logarithmic equation?
Yes.
Yes, because the unknown appears at least in front of one of the logs. Okay, and then I see that two logs are equal. So what can I conclude? What can I in principle conclude? Yes? Yes, but this is not trivial. If you are a good mathematician, you need to doubt about it. Okay? It is not always the case. Okay, for example, if I ask you x squared, so for example, if I ask you x squared is equal to 5 to the 2, I just want to say that you are comparing the structure on the left with the structure on the right. You see that everything fits. If this is going to work, then this has to be equal to that, yes? But I'm just telling you, the comparison of these structures, you should be careful about. Here, can you just compare the structures and get the answer here? What's the answer? Yes? What's the answer? So you get x is equal to 5, but that is not complete, because there is another one which is minus 5.
Plus minus.
It is plus minus. But what I'm saying is that if you get used to just blindly compare the structures, you get some answers, not the whole answers. Yes? Why is this happening? Let me just put it in a little bit more advanced context. Because if you draw the graph of this function, you will get something like this. this function is, this is a big terminology for a simple thing. This function is not injective, okay, or one-to-one. A function, so this is one-to-one function, injective. This is more fancy way for the same thing. Okay, so when we say this function is not injective or is not one-to-one, what does it mean? It means that if I draw a horizontal line, it will cut the graph of the function more than one point. And that is exactly because this is happening. So if I want to compare the structures, if I just say x is equal to 5, I'm only considering one of the scenarios. But there is another scenario here, it's -5. So this means that if you want to compare the structures, this method of solving equations is valid, is complete, if your function is injective, if your function is one-to-one. And it means that if I give you GeoGebra, you go and draw the graph of this function. Somehow, I don't know, I don't want to be very precise, but this would be a function of this form. Okay, but do you see, is this curve injective or not?
Yes.
Because if I draw some lines horizontally, how much intersection I will get? At most one. Whenever you get at most one intersection, it means comparison of a structure is valid. You don't lose anything. But if the function is not injective, if you just want to compare the structures, you get the correct answers. That is for sure. The answers that you get are indeed answers, but they are not the whole scenario. Is that understandable? Okay? But remember, these are more advanced things, but I want you to at least know about them. Logarithmic function is an injective function. So if you draw the graph of this function, it would be something like that. You don't have any double intersections. For example, if you draw the function of sine function, this would be something like this. Yeah, it goes forever. But is it injective? No, because if I do this, and this is, you will learn next year. If I ask you solve this equation, sine x equals to 1/2. If you remember from trigonometry, sine, do you remember which angle was 1/2? No, 30. Okay? So can I conclude x is equal to 30? No. Is x equal to 30 a correct solution or not?
It is
It is a solution, but not the whole scenario. Yes, because I am comparing the structures. What I'm saying is that if I ask you sine x is equal to sine of 30 degrees, if I ask you what is x, many of the novice students would say x is equal to 30, which is completely correct, but not the whole story. You are just giving me one possible answer by comparing the structures, yes? But is comparing the structure the whole story for sine function? No, because if you draw the sine function, it is not injective. And then it means that if this is 1/2, how many intersections you see if you continue?
Infinite.
Infinitely many. So if you just say 30, you are just giving one out of infinitely many answers. Is that understandable? Okay, but the good point is that you can compare the logs structure-wise, because the log function is a one-to-one function. Is that understandable? So in principle, I can say this.
How can you conclude that it's injective?
No, that's a little bit hard.
Without
Yeah, it's a little bit higher than the level, but I want you to understand that's the same concept. Okay, so if I ask you the log of x to the base a is equal to the log of y to the base a, what you can conclude? What you can conclude? X is equal to y. Now my question, is there any other possibilities? No. If someone asks you why, you would say that my teacher said that this function is injective. But you should be able to explain what's the meaning of injective, yes? That is exactly the same idea. So the core is not hard, but mathematicians, after understanding what's going on, they formalize it, write it in a very formal and probably not very friendly language. But if you learn the language, it's not hard at all. By the way, that's the only language I understand. I had a lot of problems with physicists because they didn't care about formal math language. They knew a lot of mathematics, what they started. I had a very hard time to reading a physicist article, except those one who were written by people who really respect the language. And this is actually, by the way, this happens. Yes?
So what if they ask me, how do you know it's injective? What do I
No,
say?
at this time, at this moment, you don't know how analytically show that.
Okay. So
But it is better to say something. You don't need to be silent. You should say that, okay, I know how at least demonstrate it for you graphically.
Yeah.
Don't underestimate that. This is above knowledge. I would say if you can elaborate this, it means that you understand things very good.
Okay. So
At least you know that I know everything, but I don't know it at the analytic level. And then hopefully I will learn it in the future if I am interested.
So I just tell them I don't know it yet.
Well, not analytically, but you know it now. Okay, so this means that these two are equivalent. If x is equal to y, of course, there is no surprise. If two numbers are the same, their logs are also the same. But if the logs are the same, because log is injective, we can conclude that x is equal to y. So now, if I ask you to solve this question, can you tell me what's the answer? Can I compare structures here for log function?
Yes.
Yes. Why? Because it's injective. A better name for injective is 1-to-1. By the way, 1-to-1 is clear because for every value you get one value. That's the meaning of 1-to-1. Yes. For each value of the y-axis, you get at most one value for the x-axis. Okay. So what is the answer to this problem? Just tell me. X plus 1 is equal to 7. X is equal to what? 6. You need to be a little bit more careful about the answer because it might have a fake root, but of course not in this case because I haven't done any reversible operations or things like that. So definitely x equals to 6 is the answer. Is that understandable?
Yes.
Okay, so now let me give you another example so that how you can solve the problem here. For example, let me solve this simple problem. The people who actually learn this, if I can teach you this, then you will learn. By the way, did you read my message when I sent you? Oh, yeah, yes. So actually, that physicist exactly and simply expressed my feeling about teaching. Okay, so log of this one equals to that one. Can I immediately jump to this conclusion that x plus 4 is equal to 2x plus 11? No, because the comparison of structures is failing here. Because unfortunately, because of this nasty 1/2. So I want you to understand this, I cannot immediately conclude that x plus 4 should be equal to this. Do you agree? Because of this unfortunate 1/2 here. Okay, but now we need to crack it somehow. You need to learn, you need to remind yourself about all your logarithmic knowledge. By the way, your logarithm knowledge is good at this level. If you forget it, that's your problem, not mine, okay? Okay. So, yeah, that you need to value it. So that is a very bad habit here. You learn but forget. Why? Isn't it useless? You spend so much energy and time to learn something and then immediately forget it and don't care about things for forgetting that. So you need to value it more. Okay, can you tell me what to do now here? What's your opinion? Is it a logarithmic equation? Yes, because it contains equality. It contains an unknown. An unknown appears in front of a log, and here 2 logs. And then I want to find the value for x. Yes?
We can take 1/2 and put it as a power.
Power there, yes? And then, so let us follow, because I want you to understand that what you understand correctly works. So what you write, you put it here. Yes? Is that understandable? And now, can I do comparison here? A structure comparison, is it possible?
Yep.
Yes. Because the log in base 10 of a number is equal to the log of another number in the same base 10. So what can I conclude? I can conclude that x plus 4 is equal. What is another way of writing this? Square root of 2x plus 11. If you reach to this point, you are relieved. If you have already, if you remember that, what is the name of that equation now? What's the name of that equation?
Quadratic.
No, there was a name for that kind of equations. So you see, the trouble starts from now. And this is not because you didn't learn when I was teaching that. Do you remember we solved horrible problems on the board? It's called root equations. Yes? So it means that if you change this problem, you see, always in mathematics, this is a new topic. I didn't solve this problem. I learned how to reduce it to a problem that I already know how to solve. And then I am relieved and I continue from there. I don't care. When I realize this, I am relieved in the exam because I know that I know how to solve it, because I already know how to solve these problems. But it doesn't need to solve, if you are a little bit smarter, you really don't need to go trouble to solve root equations. An alternative, yes, please.
You can make it the quadratic equation.
Here, yes, but even before reaching to that point. Yes, you are right. If I want to solve it, I'm not talking about how to solve this problem. You are right. I need to raise it, and then it becomes a quadratic equation, and I need to solve it. But I could come exactly to this by this trick. First, do you remember I don't know what is called, this is phrase. So I hate fractions, yes? So I multiply by 2. Yes? And then I put 2 on top of this. And then I compare the structure. So then x plus 4, it becomes exactly that equation. Yes? It doesn't matter. If you write this, it is 100% acceptable. If you write this, that's also acceptable. Let us solve this problem. I have 2 or 3 minutes left. Okay, so if I raise it to power 2, it becomes what? X squared plus 8x plus 16. On the right-hand side, I have 2x plus 11. What should I do? I have to move everything to the left. What is the answer? Yes? And then you need to solve this equation and find the answers. So let us solve it. So how many of you can immediately solve this? Yes?
5 and 1, or -5 and -1.
Negative, yes, -1 and -5. Okay, but if you want to do it using ABC formula, so I put a -6 here, plus or minus. Square it in your head. What is that? 36. 4 times this one times that one is 20. Subtract them, 16. Square it is 4. So you don't need to write this. It's 4. And then divided by 2. So there are 2 answers. So you see the prediction was correct. -1, -5. Yes or no?
Yes.
Okay. But you have to be careful. You have to be careful. What was your original equation? Do you remember? Your original equation was this. So you shouldn't accept them immediately. You need to go and check them that everything is okay. Yes or no? So you put -1 here. Do you have any problem with this log? If I put -1 here, it becomes positive. So as far as this log is concerned, I don't have any problems. I put -1 here, I don't have any problems. It becomes none. So they are defined. So this number is acceptable. But what about -5? I immediately run to some trouble, yes? If I put -5 here, what's the answer?
-1.
It's log of -1, which is not defined. So it's a false root. Yes? So I just got one answer. Is that correct? By the way, let us check the answer. Do you believe in that? If I put -1 here, it becomes log of 3. On the right-hand side, it becomes 1/2, question mark, log of 9. Do you agree that this is correct or not?
Yes.
Yep. Yes, because 3, this is 3 to power 2, 2 goes there and cancel that one. Log of 3 is equal to log of 3. So the answer that I got was correct, but I also got a false root. Yes, you need to write it down and then say it is false because it doesn't fit to this equality. Is that understandable? So you need to change the way that you learn mathematics. You should be active in it. Otherwise, it's just a boring subject. Probably the most boring subject, yes? I come here and I start giving you structures, follow this, follow that, follow that. Yes. But you need to feel, sometimes you are flexible in following that way, sometimes you are not. And you also start enjoying that, okay, I want not to be so flexible, yes? Yes, thank you very much. See you tomorrow with harder problems. Okay? Well, I want to show you something. So let me thanks people here. I don't know how many people are here. 5. Are we 5? Absolutely. Pardon? So let me end. Yes, let me end this stream. Thank you for being with me here.